Okay, for problem number 41, the first thing you want to do is factor out your GCF. So take a look at your numbers first. I've got 10, 23, and 12. Well, there's nothing because 23 is prime. Like if you took and broke these guys down, 10 is 2 times 5. That's the prime factorization, right? You can think about that like if you make a little tree, we would get 2 and 5 out. And that's it. These are both prime numbers, so this is the prime factorization. If you take the number 12, you can break that down into 2 and 6 and 2 and 3. So this is 2 times 2 times 3. Okay, but here's the problem. 23, well, 23 is prime. So the only numbers that work out are 1 and 23. So we can't factor a number out. Okay, we can factor out a variable here. We can factor out an x. They all have an x in common. So the first thing to do is to pull out that x. So what we're left with is 10x squared minus 23x plus 12. Now forget about this green x out in the front. It's just going to come along for a ride for the rest of the problem. What we want to concern ourselves is with this. Now this is not easy to factor, so here's the trick. Take the first number and the last number and multiply them together. And then look for the factoring pairs of 120. So I'm going to write down every possible number, and it's going to be a lot, every possible number that can multiply together to give me to 120. So for example, 1 and 120. 2 and 60 multiplied together to give 120. 3 and 40. 4 and 30. See here, 120 is divisible by 5. I know that. You might have to do some of this stuff out. So 5 would be 24, I believe. Okay. 6 and 20. 7 doesn't go into it, but I think 8 probably does. Let's just check here. 8 goes in here once. 8, 4, 0. So 8 and 15. Okay, and you keep going down on this list. Now this takes a little bit of time to do this, but here's the thing. What you're looking for on this list, by the way, 9 doesn't go into there, but 10 does with 12. Now once I hit 10, 11 doesn't go into there, and my next number would be 12, but it's already over here, so I know it would match up with 10. So I can stop at that point. Now this is actually a quite extensive list. Usually they're not this bad. So what I'm going to do now is I'm going to take a look at each of these numbers, and I'm going to say, can I add or subtract to get this middle number right here? So do any of these add or subtract to get negative 23? Well, if I made this a negative 8, I made this a negative 15, they would still multiply together to give me 120, but if I added them, I would get negative 23. So what I'm going to do is I'm going to split, I'm going to break up the middle thing right here, and I'm just going to rewrite it as the 8 and the 15. It doesn't matter which order you go in. I'm going to do the 15 here, so minus 15x minus 8x plus 12. Now what I want you to notice is that negative 15 minus 8x, these two guys right here, they would give us negative 23x. So all I've done is I've rewritten negative 23x as negative 15x and negative 8x. Okay, that's it. So there's nothing special there. But the nice part about writing them like this is now that I have 4 terms, I'm going to factor by grouping. So I'm going to group these guys together. So the x still comes along for the ride out in front. Now here, with the first two, I'm going to factor out what's in common, the GCF. Okay, so the biggest thing I can factor out is a 5 and an x. And what's left over is a 2 minus, oops, this should have been squared. Sorry, 2x. Right, because it's 10x squared. Okay, so I factor out an x, and I can factor out the 5, so I'll be left with 2x minus 3. Now look, if you take the 5x and you multiply it back in, you distribute it back in, you'd end up right back here. 5x times 2x is 10x squared. 5x times negative 3 is negative 15x. Now back here, I'll factor out what I can. I can factor out, I'm going to pull out a negative, okay, and 4 is the biggest number I can factor out. So what's left is going to be 2x. I factored a negative, so this will be, it's going to change signs here. So this will be minus 3 as well, just like that. Now again, if you take negative 4 and you multiply it back in, you get negative 8x, and you get positive 12, because a negative times a negative is a positive. Now, I'm going to stop writing that guy in green. I've got 5x minus 4, and I've got 2x minus 3 and 2x minus 3. The back guys are the same, so I'm going to factor that out. So when I factor that out of these two things, forget about the x in front. Okay, let me write it over here so it's less confusing for you. I've got 5x times 2x minus 3 minus 4 times 2x minus 3. It's like if you had 5x times a minus 4 times a, and I asked you to factor, you would say, oh, I can pull an a out. So you go like this. Same deal here. I'm going to pull out a 2x minus 3, and I'm left with a 5x minus 4. Just like that. So that's the complete factorization there. Okay, now one of the things that you can do is go to a site like Wolfram Alpha. Okay, so once I'm at Wolfram Alpha, I can ask it to factor something like that. So if I wanted to, I could go back and I could type this original problem in, and I could ask it to factor, and it'll give me the steps out for it if you have the Pro version, which I think is like a couple dollars. But I'm not saying you even have to do that, because I think if you just follow these steps right here, you'll be able to get to the solution on all these problems. So let me work those other two problems as well. Okay, so let me find my pen here. Okay, so I think the other one was problem 45. Okay, so that is 10 a to the third minus 6a squared minus 4a. Okay, first thing we'll do is we'll factor out the GCF. Now, we first look at the numbers and we say, is there anything common in all of these guys? And the answer is yes, there's a 2. So let's factor out a 2. And then we look at the letters and we say, is there anything that we can factor out of the letters? And we can pull out an A. That doesn't matter whether you use parentheses or brackets. I like brackets, but you can use whatever you want. So what's left? Well, 5a squared minus 3a minus 2, just like that. Now, if you're wondering, did you do that step right or not, take the 2a and distribute it back into each of these and see if you get 10a to the third minus 6a squared minus 4a. And you should. Okay, now what I need to do is I need to factor this piece right here. So let me just do that as a side note, okay? So I've got 5a squared minus 3a minus 2. It's a nice trinomial, but this leading coefficient out here is a mess. So what I'm going to do is I'm going to take the first guy and multiply it by the last guy. So 5 times 2 is 10. Now if you want to do 5 times negative 2, you can get negative 10. It really is irrelevant. Okay, so watch. Now I take a look at this and I look at all the things that multiply together to give me 10. So 1 and 10, 2 and 5, and that's it. We're done. And now I say, do any of these add or subtract to give me the middle guy right here? And the answer is yes. 2 and 5 can give me negative 3 if I write it like this. So 5a squared minus 5a plus 2a minus 2. I used the 2 and the 5 here and here. And if you take negative 5a and add it to 2a, you get negative 3a. So I just took this and I rewrote it in a special way. Now I'm going to factor by grouping. So I'm going to take the first two and I'm going to say, what can I factor out? Well, I can factor out a 5a. And then what am I left with? A minus 1. And then the last two, I'm going to say, what can I factor out? Well, a 2. So I'm left with a minus 1. Now the important part with factoring by grouping is that these last guys are the same. So again, I'm going to factor that out. So a minus 1 gets pulled up to the front, and what I'm left with is 5a plus 2. So this guy right here breaks down into this. So what we're left with is 2a times a minus 1 times 5a plus 2. That's it. This is not too bad. Okay, let's take a look at 53. Or excuse me, 53. Okay, so 53 says we have 24x squared y minus 6xy minus 45y. Okay, so we'll look at the numbers first and we'll say, can we pull anything out? Well, 6 only has 2 and 3. I can't factor 2 out of 45, so let's try the 3. Well, 24 is divisible by 3, so is 6, so is 45. So we'll pull a 3 out. Now, I can only pull a y out of everything, because everything's got a y, but not everything has an x in it. So we'll pull the y out. Now, what am I left with? Well, 24 divided by 3 is 8. And I pulled the y out already, so I'm left with x squared. 6 divided by 3 is 2, and I pulled out a y already, so I just have the x. And then 45 divided by 3 is 15, and I'm done with the y that I already got factored out. So let's take a look at this thing right here, because we've got to factor that. So we've got 8x squared minus 2x minus 15. So I'm looking for a special way of writing 2x, negative 2x. So I'm going to take 15, I'm going to multiply it by 8, and that's going to be an ugly mess. So let's see here. I think that again is 120. Ugh. Okay. That's just 120's just got a lot of factors in it, so it's kind of a pain. We already did it. It's up here. Okay. So let's just quickly write them down again because I want them down here. Okay. So 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5, what was it again? 5 and 24, I think. Is that what I wrote down before? Yeah, 5 and 24. 6 and 20, 7 doesn't go into there. We said 8 went into there 15 times. 9 doesn't go into there 10 and 12. Okay, but that's as far as we can go. Now we're looking for any of these that can add or subtract to give me a 2. Well, 10 and 12 are the closest, so they're going to be, if I do a negative 12 and a positive 10, I can get this guy. So we'll do 8x squared minus 12x plus 10x minus 15. Now, if you switch the order around, not a big deal. You just got to factor out a negative in the back guy, but it will work out the same. So let's group them together. The first two guys I can factor out. Well, for the numbers I can factor out a 4, and then I can also factor out an x. So I'm left with 2x minus 3. And on these back two guys I can factor out a 5, and I'm left with 2x minus 3. And I know I did it right because these back pieces are the same. So this is going to give me 2x minus 3 times 4x plus 5. So this is going to replace this guy. So we're left with 3y times 2x minus 3 times 4x plus 5, just like that. And that's it. So just, if the answers in the book are like, if this guy is here and this guy's there, I mean, it doesn't matter because it's multiplication that's commutative. So we can switch the order of all 3 of these factors if we wanted to. Okay? So hopefully that helps you out.